The first thing that we're going to do before we even really look at these problems is think about what type of problem this is. Each of these equations of planes and lines problem is saying, find either the vector equation or the general equation for some planar line given some stuff. So maybe that stuff is another line and we want it to be parallel to that line, or we want it to be perpendicular to that line. Maybe that stuff is another plane. So a good way to approach this, given that really these questions can be asked in so many different ways, that stuff could really be anything. I mean, it could be points, it could be vectors, it could be lines, it could be planes. So what is a good way to approach all of these problems? So I've been thinking about what we could call steps, and maybe the first step here would be to write down an empty version or generic version of the equation that you want. And the reason that you would do this is to get a clear idea as to what you need in order to fill it in. So an example of this would be just saying x, y, z is equal to blank plus t times blank. And this would be the vector equation of a line. And I know that this blank right here needs to be a point, and this blank right here needs to be a direction vector. So we're like, okay, I'm gonna have to figure out how I fill those two things in. Or maybe you would write ax plus by plus cz is equal to d, and that is the general equation of a plane. I mean, maybe that's what you're asked for. And that a, b, c, my coefficients there, is a normal vector. So over here in the general equation, we have a direction vector. The direction vector is parallel. Remember, the normal vector is perpendicular. And then we would also need a point to find d. So that would be a good place to start, is just by like writing down your generic equation and being like, what do I need? So the first thing is figure out what you need. Now, the second thing is figure out what you have. And a good way to figure out what you have is to draw pictures. So when you're looking at this stuff, we're going to extract points, vectors, lines, planes from the stuff. And we're going to kind of understand, okay, so I have this other line and I have a vector parallel to this other line. Which brings us to our third thing, draw pictures. And those pictures are gonna help you figure out how to get what you need from what you have. Planes are really hard to draw. If you watched my videos that you were supposed to watch, then you know that I can't draw planes. So when I need to draw a plane, I typically just draw it as a line and write P next to it to be like, hey, look, this is a plane. So we'll make a note that we can draw planes looking like lines. If you are an amazing artist, great, go ahead, draw your planes. Okay, so these are the steps we're gonna follow, and we're gonna try to use these things to answer every single question, to have this be the steps for no matter what that stuff is, no matter what it's asking, we can follow this. You guys ready to do a problem? Yep. Okay, let's look at the first one then. It says, given the points P, Q, and R, well, the first one's not asking for a plane or a line, but we're still gonna do it because a lot of times these problems build up on themselves. So it's possible that the magnitude and this vector are gonna be useful. So what this is asking for right here, PQ, this is the vector between P and Q. And finding a vector between 2 points is usually really straightforward. We just do the subtraction. So I'm doing Q minus P. So my vector PQ will be 2 minus 1, that's 1. Minus 1 minus negative 2, that's minus 1 plus 2. That's 1, and then 2 minus 1, that is also 1. And just to make sure that we understand where that came from, we were like 2 minus 1, comma, minus 1 minus negative 2, comma, 2 minus 1. And then how do we find the magnitude? We stick it in the little lines to represent magnitude, and we do our square root thing, where I do the square root of each thing squared to get the square root of 3. Okay, hopefully that's not where you guys were having trouble. Okay, so now I want to find the parametric and vector equations of a line that's passing through 2 points. So let's go over to the side here and try to use the steps that we have to figure out how I can get the equation for this line. So my step 1, we said, so vector and parametric equations, I remind you, are really the same thing. They're just written a little bit differently. Parametric equations are just taking the little like vectors away. So I'm gonna draw my generic vector equation, or my empty vector equation here. And my empty vector equation, this is gonna be a line, but it's in R3 because there are 3 components there. So I have my x, y, z is equal to some point plus t times some direction vector. So this right here is going to be a point, and this is going to be a direction vector. So then, in other words, that is what I need. Do I have points here? What are the points that I'm given here? So I want my line to pass through P and Q. So it turns out R actually has nothing to do with this problem yet. So P and Q are my points. So for the point, I can use either of them. I just need 1 point, I have 2, but so I can put P, 1, negative 2, 1 here, or Q, 2, negative 1, 2. Okay, so I have my points. I don't have a direction vector. I don't know why I keep forgetting to write the word vector. So this brings us to our step 2, which is extract whatever you need from stuff. Well, in this case, my stuff is just P and Q. This is like stuff. Okay, so what I need is a direction vector. What I have is 2 points. So if I make that very clear over here, we can say, I need a direction vector. What I have is 2 points. Okay, so then the third step says to draw some pictures. So let's draw a picture. What I want is a line. So let's draw my line. That's going to be my line. I'll call it L. What I have is 2 points. I have a P, I have a Q. What I need is a vector that is parallel to this line. So how can I get that vector from P and Q? Well, I kind of already have it. If I draw a vector through P and Q, is that parallel to my line? Yep. So P and Q on the line. So PQ parallel to the line, and is thus a direction vector. Good. So now I can go over here and fill things in. I can use whichever point I want, 1, -2, 1, and my direction vector PQ, which we found was 1, 1, 1. And that's my final answer. Okay. Are there any questions about what we just did here? Then let's do 1C. Oh, the parametric equation. Thank you, Daniel. So for my parametric equation, so this was my vector equation. For my parametric equation, I just take the vectors away from my vector equation. So for my parametric equations, I'll have x is equal to 1 plus t, y is equal to -2 plus t, and z is equal to 1 plus t. So we can easily go back and forth between the two. Okay, let's look at 1C. Does the point R lie on the line found in B? Well, R is 3, 0, 3. So remember, to determine whether or not a point is on a line, we want to use the parametric equations. And so I'm just going to replace x with 3, y with 0, and z with 3. So I'll have 3 is equal to 1 plus t for x. Zero is equal to -2 plus t for y, and 3 is equal to 1 plus t for z. So here I get t is equal to 2, t is equal to 2, and t is equal to 2. They're all the same. What does that tell us? If they're all the same, what does that tell us? Is the point on the line or not? You got it, Daniel. On the line. Yes. R is on the line. Okay, are there any questions about 1 before we go on to maybe one of the more challenging problems? Oops. Okay, so A is going to be simple. We're not looking for a planar line. It just asks, are U and W orthogonal? How do I determine if two vectors are orthogonal? Someone knows, right? If two given vectors, what is they? So zero's involved here. Something has to equal 0. Not U cross W. What's the other like vector multiplication? You got it. You dot V or W. So here, this is check if U dot W is equal to 0. So U dot W here is 430 dot 2012, which gives me 8 plus 0 plus 0, which is equal to 8, which is not equal to 0. So are they orthogonal? No. Good, okay. So now to B brings us to a little bit of a more challenging question. Find a vector equation of the line in R3 that passes through this point and is orthogonal to both U and W. Okay, so let's think about this. Oops. So what I want here is vector equation of a line through the point, just to kind of remind ourselves so we don't have to keep going backwards, 5, 5, 5. And perpendicular to, was it U and W? U and W. Okay, so we're gonna start this off the same way. We're going to write our like empty or our generic vector equation because what we want is a vector equation. So my vector equation will be XYZ is equal to some point plus T times some direction vector. So what I need here is my point and my direction vector. Do I have a point? Am I given a point? Yes. That point is 5, 5, 5. So that is given explicitly. Okay, the direction vector is not given explicitly, so this is what I'm gonna need. I'm gonna call it D. And now what I am given, I'm given vectors U and W, and both of them should be orthogonal to my line. So I'm just gonna draw a picture of my line over here. This is my line, let's call it L. And then I have some vector U, and I know that U is orthogonal to my line. And I have some vector V, and that's gonna be like sticking out of the line here. Or I'm sorry, W, and W is also orthogonal to the line. And what I need, my direction, is my direction vector. Now remember, direction vectors are parallel. So I need this vector that's parallel to my line. Look at this. U is perpendicular to the line. W is perpendicular to the line. If D is parallel to the line, is it also perpendicular to both U and W? I mean, look at the picture. You can probably tell from the picture. Is D perpendicular to both U and W? Yes or no? Well, it's the same direction as the line, right? I know U and W are perpendicular to the line, so then yes, of course they're perpendicular to D. So here I could say yes, because D parallel to L. We can also, from the picture, we can see that. Look, D is clearly perpendicular to U. I can draw it so that it's really obvious. Well, it's also perpendicular to W. Now, how do I find a vector that's perpendicular to two given vectors? And the answer to this question is one that you're going to really need to be comfortable with if you're not yet. How do you do that? What's the only thing we've learned that results in a new vector? Yes, Daniel, you got it, the cross product. The answer to this is the cross product. So if you did not know the answer to that question, you need to make sure that from now on you do know the answer to that question, because it's going to be an important thing. If I have two vectors and I want another vector perpendicular to both of them, I'm using the cross product. Okay, so because I'm bad at drawing, I'm just going to really quickly try to give you guys here a picture of what's going on with some pins, if I can find a third pin. Okay, so do you guys all see me? Do you see the video? Okay, so let's say that blue pin right here is my line. Then red pin is one of my direction vectors. Let's say that red pin is U. And let's say that white pin is parallel to the line. Is white pin also perpendicular to red pin? Yeah. So in other words, if red pin is perpendicular to the line and white pin is parallel to the line, then white pin is also perpendicular to red pin. So in other words, I can think of my direction vector and my line as being in the same place. So a way that I could draw that over here would be, instead of drawing my direction vector by the line, I can even draw my direction vector as being a vector that's on the line. And that might help you to really see that, oh, hey, look, of course it's perpendicular to both of them. I drew U and W specifically to be perpendicular to that direction. Okay, so now we are going to do the cross product, and U cross W is equal to, let's go remind ourselves of what they are, 4, 3, 0, 2, 0, 12. So this is going to be cross out the first column. Oh, what happened to here? Okay, all right. So cross out the first column and we get 36 minus 0. Cross out the second column and I get 48 minus 0, but I got to stick a negative in front of it. Cross out the third column and I get 0 minus 12. And that will be my direction vector. So my point was 5, 5, 5. And now I found my direction vector. Are there any questions about what I just did here? Okay, let's go and look at C then. Find the general form. So here I want a general form of a plane in R3 that passes through the origin and is parallel to U and V. Okay, so to C, my plane through the origin, general equation, plane through origin, parallel to U and V. Okay, so again, we're gonna start off by writing our sort of empty or our generic equation. But this time that generic equation is not a vector equation, it's the general equation. So you need to be really comfortable with both of these. My general equation for a plane looks like this, where we've said that so what I need here is the ABC, and that's my normal vector. And I need a point in order to solve for D. Do I have a point? What's my point here? Oh, sorry, I'm yawning. What's my point here, guys? Plane that passes through what? My plane passes through the origin. So it passes through the origin. That's my point. So my point is 0, 0, 0 because it passes through the origin. Okay, in this case, the fact that it's parallel to U and V, that's like my stuff. So let's draw a picture. I want a plane. Remember I've said I suck at drawing planes, so I draw planes as lines. So that's my plane. And now I know that this plane is going to be parallel to U. So I'm going to draw U kind of on the plane. And it's also going to be parallel to V. So U and V are not necessarily parallel, but I'm going to draw them as if they are because it makes my life easier. Good. Now, what did I need? I need my normal vector. Direction vectors are parallel. What are normal vectors? What's the relationship between a normal vector and the plane? Is it parallel, perpendicular, or neither? So this is just a thing you have to memorize. It's not a thing to like understand. It's just definition of a normal vector is that it's what? If you go way back to like Sec 3 when you were doing normal lines, maybe Sec 4, I don't know, possibly Sec 5. Normal lines, what does normal mean? So maybe a good way to think about this is we have two types of vectors. We have normal vectors and we have direction vectors. And for the most part, those are the vectors that we're dealing with when we are dealing with planes and lines. One of them is going to be parallel and one of them is going to be perpendicular. But what does the word direction mean? Do you think that the direction vector is giving me the direction of the line, or is it giving me something perpendicular to the line? The direction vector is going to give me the direction of the line. So it's going to be parallel, which leaves the normal vector to be what? Yes, yes. So my normal vector is always perpendicular. The normal vector by definition is a vector that's orthogonal. So normal vector is perpendicular. And if you do not have that memorized, these problems are for sure going to be really challenging. You need to be like clear. Direction, that means parallel. Perpendicular, normal, go together. Okay, so what I need is my normal vector, my perpendicular vector. So I need a vector here that's perpendicular to P. Look at my picture. How am I going to find N given U and V? I want you to think about what we did in the last question. How do I find a vector perpendicular to two given vectors? Bring it up so the answer is on the page. How do I find a vector perpendicular to two given vectors? The answer is right in front of you. You got it, Andrea. The cross product. So here we can see, we can see from the picture that the normal vector is perpendicular to U and V. So do the cross product. Okay, so in this case, my normal vector is going to equal to U cross V. I'll just go remind ourselves what U and V are. U is 430, V is negative 681. Cross out the first column, I get 3 minus 0, that's 3. Cross out the second column, I get 4 minus 0, so that becomes negative 4. And cross out the third column, I get 32 minus negative 18, so that's 32 plus 18, which is 50. That's my normal vector. The normal vector, remember, is the ABC. So this is 3x minus 4y plus 50z is equal to d. And then we plug in the point to solve for d. Yesterday in class, we said that if it passes through the origin, d will always be 0. That said, we can always still just plug into c. So I can get 3 times 0 minus 4 times 0 plus 50 times 0 is equal to d. 0 equals d. So then that is my general equation here. So notice here, knowing the answer to this question, how do I find a vector perpendicular to two given vectors? The cross product was super important. So I'm going to highlight that. That is how we ended up doing both of these questions. Okay, are there any questions about this before we look at number 3? Okay, so here we're given 3 points. And I want to find the vector equation of the plane that passes through these 3 points. So same as usual, I'm going to start by writing down my empty equation. So this time it's a plane. How many direction vectors do I need for a plane? I need 1 for a line. How many do I need for a plane? 2, you got it. Plus t times my first direction vector plus r times my second direction vector. Okay, so in this case, I have points. I'm given 3 points. I can use any of those 3 points. So 1, 2, 3, negative 1, 0, 3, or 2, 1, negative 3. I already forgot Q. Come on, no. Negative 1, 0, 3. So that means that what I really need here is 2 direction vectors. So I'm going to draw my plane. This time I'm going to draw my plane like this. I could really draw it as a line and it would still be fine. But I have 3 points here, so I might as well give my space to draw them. I have those 3 points on my plane. How am I going to find vectors on this plane given 3 points on this plane? And I'll give you a hint. This goes back to the first question we did when we had 2 points on a line. Bring you back to what I'm talking about. We had 2 points on a line. How did we find a direction vector? We found the vector through those points. We did the minus. Good job, Daniel. Okay, so here, if I draw vectors through those points, they are clearly on the plane. So vectors through points on a planar line are direction vectors. So that means my direction vectors here, I could use PQ, I could use PR, I could use QR, but how many do I need? 2. So I don't need all 3 of those. I can use whichever ones I want. So I'm just going to go with PQ and QR. So remember, that's the minus thing. So it's Q minus R, minus 1 minus 1, 0 minus 2, 3 minus 3, negative 2, 0, 2 minus 1, 1 minus 2, minus 3 minus 3. That gives me 1, minus 1, negative 6. Well, guess what? That's it. Now I have everything. I have 2 points and I have 2 direction. I have 3 points and 2 direction vectors, but I only need 1 point. So I'm just going to pick a random point. I'll go with Q, why not? And voila, there you go. So notice the challenging part of this problem is not the math at all. Literally the math here was -1, right? The challenging part is figuring out how to get what you need from what you have. So like, you really need to know what you need, and you need to be clear about what you have as well. Okay, let's look at D. Find the general equation of the plane that passes through these 3 points. So this is going to be a question that you see a lot, and that is, how do you get from a vector equation to a general equation of a plane? You do the cross product of the direction vectors. We could draw pictures, but it's going to show up so much that you should really just be comfortable with that. So I'm still going to start off the same way. I'm going to write my generic version. And be clear about what I need to write this. To find that normal vector, this is what I was saying. We do the cross product of the direction vectors. So my n will be equal, actually, to D1 cross D2. Cross out the first column, cross out the second column, cross out the third column to get that. So then that's my normal vector. I plug my normal vector in. I don't know what D is yet, so now I plug in my point. I'm going to plug in the -103, but I could also plug in Q or a P or R. I can plug in any of the 3 points and I should get the same D. So here I'll have 12 times -1 minus 12 times 0 plus 4 times 3. So this is -12 minus 0 plus 12. So D is actually 0. Turns out this plane passes through the origin. That's my final answer for this one. Oh, oops, sorry. All right, are there any questions about this? Okay, so let's look at C, the last problem we're gonna do. Do you guys find that this is helpful, or do you feel like you're starting to understand things a little bit more, or is this just like you're still totally lost? Good news. Awesome. Okay, so last thing, C here, I want a vector equation, I'm sorry, in B I wanted a general equation of a plane, C I want a vector equation of a line. Before I even think about anything, I'm just gonna go write my empty equation. For C, I want the vector equation of a line. I know I'm in R3, so I'm like x, y, z is equal to, remember, we just need one direction vector for a line. So this is like a point plus t times the direction vector. And remember, direction vectors are parallel. Lovely. Now, let's go see what we have. This is what I need. What do I have? I have, oh look, I have a point through the point P. That's great. So that's one of the things I need. I need a point. And it's through the point P, so P, 1, 2, 3, that's my point. Now, hopefully the stuff after that is gonna help me find a direction vector. I want it perpendicular to the plane from A and B. Let's draw pictures. So I know that this line right here that I'm about to draw, I'm gonna draw my line in this color. So this is L. And I know that what I need for this line is a direction vector. I'm gonna draw the direction vector on the line because I think that maybe actually helps you to understand a little bit better. I need that direction vector. And then what I have is I have this plane. And this plane right here should be perpendicular to L. I also have the normal vector for this plane. So this is the stuff that I have. How can I use the stuff I have to get my direction vector? Remember, the direction vector just has to be parallel to the line. So all I need is a vector that's parallel to that D right there. Looking at this picture, do I have one? Do I have a vector parallel to D? In. So it turns out I can just use my normal vector from the plane as my direction vector from the line. So let's notice here. N is parallel to D. So N can be used as the direction vector of this line. So in other words, I have x, y, z is equal to my point 1, 2, 3 plus t times my direction vector 12, negative 12, 4. Okay, so the only thing that we didn't use in this session today was this formula right here. And this formula is really only going to be useful in R2, but this formula would be used when you see that what you need is perpendicular to what you have. And then that kind of covers the stuff that you're gonna have to do. Notice, drawing pictures, especially in this last case right here, drawing pictures can really be helpful. I like to think that they're always helpful, but definitely in this case right here, having that picture, just looking down and being like, oh look, D and N are parallel. I can see that from my picture. is really helpful. All right, so that is really all that I had planned to do today. Do you guys have any questions in particular you want to ask? Cool. Stop this recording then.